All right, so we'll try to write the equation for these last two circles right here. The first one is probably a little bit easier than the second. So here we're given the graph and we have to write the equation. And again, the standard form for the equation of a circle is what I'm writing right here. We need two things. We need the radius and the center. Let's start with the center. Center point of that circle is right there, and that is at the point 2 comma 3. So we can fill this in as follows. We can say, remember, this is like our h value, and this is like our k value. So x minus h would be x minus 2, and y minus k would be y minus 3. And then the radius of the circle is this purple line right here. It's going in really any direction, but I think it's easiest to pick one that goes right to an easy to identify point. So that right there is the point 0 comma 3. So we went from 0, 3 to 2, 3. That's a distance of 2. So that means the radius squared would be 2 squared, which is equal to 4. And that is our equation right there. All right, so the next one, what this is called, it's not written in standard form. This is called being written in general conic form. Some people say conic, but I say conic form. So conic, there are 4 conic sections: circles, parabolas, ellipses, and hyperbolas. And circles are probably the more basic one. So we have to do the following. I'm going to rewrite this so that the things with x's in them go together. So x squared and minus 30x. I'm going to leave a big space, and I'll tell you why shortly. And then I'm going to put the y terms together. So y squared minus 28y together. Again, I'm going to leave a big space. And then finally, I'm going to move this 417 over to the other side. This is how we would begin this problem right here. So why are we doing this? Well, if you look at this right here, if you look at our standard form for a circle, okay, and actually let me rewrite it up above so we have it on this problem as well. If you look at that right there, it's x minus something squared and then y minus something squared. So it looks like those are both perfect squares. And you might remember from earlier sections that we've talked about something called completing the square. So in order to be able to take what we have right now, number 8, and write it to make it look like this, we need to complete the square for the x terms, and we need to complete the square also for the y term. So let's try to do that right now. Let's start with the x term. So the way that we complete the square is we take half of this number, which is negative 15, and we square it, and negative 15 squared is positive 225. Whatever I do to one side, I have to do to the other, so I'm going to also add 225 over there. Same thing right here. I need to take half of negative 28, which is negative 14, and then square that to get positive 196. And whatever I do to one side, I'm going to do the same to the other. And now we can complete the square. So now this is a perfect square, and it is x minus 15 squared. Where did minus 15 come from? Minus 15 was half of that number right there. And then right here, try and see if you can finish the rest of it from this point. So this one right here, minus 28, half of that is minus 14. And then finally on the other side, we have 225 plus 196 is 421. And then minus that 417 is positive 4. So there is our circle. The center would be at the point. What makes that 0? And the answer is 15. What makes that 0? The answer is 14. And the radius is 2, because that number 4 is the radius squared. So that is how we would write the equation of a circle if they give it to us in what's called conic form. We have to complete the square.